Hello everyone, this is Nikita. Welcome to the episode 63 of Microsoft Hour of Code brought to you by Millionlights. Millionlights is a TV channel dedicated to improving skills of people and their employability. Now, let me tell you more about Microsoft Hour of Code. Microsoft Hour of Code is a series of lectures, courses, and talks by experts who are going to discuss the latest Microsoft technologies, topic related to programming, and industry forecasts that are all focused on employability. As you know, we are learning developing Microsoft SQL Server Databases. This course is basically for people pursuing computer science. This content has been created by our partner Microsoft, and today we have Malcom and Christian Bolton from Microsoft with us. Our expert will take you through tables, indexes, stored procedures, and other database objects. Learn about techniques from designing indexes, managing transactions, and optimizing performance and concurrency, and get best tips and practices. These courses can help you earn at least 4 lakhs a year, and for those who are already working, experience strongly influence pay in this job. So you can definitely get an increment in your salary. Now let's move towards the course developing Microsoft SQL Server Databases. The topics we covered in our previous episodes are implementing tables and views and some part of implementing indexes. In this episode, we will cover the remaining part of implementing indexes, and after that we will move to another topic, implementing stored procedure and functions. So let's get started with implementing indexes.
The demo scripts afterwards as well. So essentially what I'm doing is taking these scans and lookups, so these are the reads, and I'm looking at the inserts, updates and deletes, so these are the writes. And I'm joining that to get the index names and ordering it a certain way. And what this is giving me is essentially a list of indexes within this database ordered by reads ascending and writes descending. We think about, as I mentioned, the purpose of an index is to be read from. So what could you tell me about IX log recorded, Graeme?
I'd say it's not been particularly useful. We're not reading it, but we do seem to be writing to it a lot.
Exactly. So what we're essentially doing here is that we're making changes to the underlying table structure, which is forcing us to keep this index updated, but it's not actually being read from, which means it's not being used. So it only exists to be read from to improve the performance of reads. So we would use this script when reviewing a database and overhead to look for unused indexes.
Oh, okay, that's useful.
So it's a great use for this index operational stats DMV. So this guy would be a candidate for removal. It's not quite as straightforward as it's not being used ever, because this information will be reset when you restart SQL Server.
Okay.
And it will also be reset when you do index maintenance as well, unfortunately.
Okay.
So, and if you're doing index maintenance on a daily basis, as many people would do, this information will be reset and go to 0. So it's a candidate for, I'm going to look at IX log recorded to clarify whether or not it's used anywhere.
It's a flag, really, is what we're saying. Exactly, it's a red flag. Exactly. I guess we could have a scenario where once a month we have an absolutely critical report that runs that does use that index.
Exactly.
But for ever since we last restarted or we last updated the indexes, it hasn't been used.
Yeah.
Okay.
But it's a really useful scenario. So if you inherit a database, for example, and there's 12, 13, 14, 15 indexes on it, and without looking at something like this, you're not really going to know if it's used. So what we would do is try and capture this kind of information on a regular basis, and then over time we can see that it actually hasn't been used for months. Okay. So it's safe to delete.
Right, great. And as you said, we are going to make the scripts available with the course. Of
Absolutely.
If you want to download this at home and play around with looking at your indexes, then by all means you can do that.
So there's one more thing that I wanted to mention before we come off this demo, and that's around unique constraints. So if this IX log recorded, while it's been logged as 0 reads, if it was a unique index, SQL Server would use the fact that it existed in order to help the optimizer, because the fact that a unique index exists means that the data is unique. Therefore, I don't need to read the index to find that out. So there's a little bit of a caveat in there.
So just the very fact that there is a unique index means, hey, we know there's only one of these things.
Exactly.
Right, okay.
I don't need to read it to find out, because the fact that it exists is there. So something to bear in mind that if you are looking at unused indexes, that it's even harder to clarify that it's unused if it's unique.
Okay, right, good tip. Excellent. Let's switch back to the slides. We've seen a little bit about how to maintain indexes. We've seen a little bit about creating them and using include columns. What about this idea of filtered indexes? Talk to me about that.
So a filtered index is a really great feature whereby you can actually add a predicate to your index creation statement. So effectively you're adding a where clause to your index statement. And this example that we have on the right here, where we're creating a non-clustered index on address, but we're actually specifying only where the city is New York. So if I was only interested in employees in New York, then I'd have a much smaller index, because I effectively filtered it by using a where clause.
So the index only includes records where the city is New York.
Exactly.
The other ones are, so what I've got is a sort of hybrid between a heap. If this were it's a non-clustered index in this case.
Yeah.
Can I have a filtered clustered index?
Well, I mean, because the clustered index is the data itself, so you couldn't, creating a filtered clustered index would be deleting the rows in the table effectively.
Right, so this is really a non-clustered
thing.
So
it's just for non-clustered indexes, yeah.
Okay.
But if you think of examples where you've got a very big orders table, but you're only really interested in yesterday's orders, you could create a filtered index based on time. So you're just maintaining this index for a very small amount of data.
Okay. And I guess, we've listed the benefits there on the slide, I guess. Do you want to talk me through those?
Sure. So it's a faster response time. You think if you've got 1 million rows in a table, but you're only interested in the top 100, so you could create a filtered index which included those top 100, so that's less to store, because non-clustered indexes, remember, are separate objects from the clustered index or from the underlying table structure itself, which means it's going to be faster to traverse that index because it's much smaller and it has a smaller storage requirement, and it's going to be faster to rebuild as well, because you've only got a very small subset.
So if I'm trying to get rid of the fragmentation, it's only that one subset of the index that needs to rebuild.
Exactly,
okay.
Exactly. And it shares some similarities with indexed views as well, in the fact that, remember, we could create a view which gave me a subset of data, and then I could create an index on that view to persist it down. So the filtered index is a much cheaper way of achieving what we would have done with an index view.
Okay, great. So I mentioned fragmentation, and we've talked about it a few times. Let's drill into that a little bit more.
Yeah, absolutely. So fragmentation occurs when data changes. Data changes cause pages to split. So we've, as you said, we've touched on this a number of times, where we've got data in perfect amount of order, and we need to insert something in the middle, and it causes this page to split. So there's two types of fragmentation that we often talk about. So the first is internal fragmentation, so where the pages aren't full, and we saw that example of 65% full average page size. And we also have this external fragmentation when pages are not in the right logical sequence, so the kind of the physical ordering on disk is the way to think of that, and that's where we have these references to the next page is
so it kind of spills over onto we've run out of run out of space on the actual page where this index is, so we're going to reference you off to,
Yeah.
in my address book, it might be sticky notes I've added to the back.
Yeah, so we're splitting a page, but there's no room to put that new page physically next to the first page. So it's now at the end of the data file, and we've got this kind of traversing around the data file to meet that requirement.
All right.
So detecting fragmentation, we've seen in the demo. So we have you can have a look at index properties in SQL Server Management Studio. It's not very common to do it this way because it's actually quite an expensive operation. And with the overhead of SQL Server Management Studio, if you've got big tables and big indexes, it can take quite a long time to get that information out. So we would most often use DMDB for physical index physical stats, which we saw in the previous demo. So fill factor and pad index. So these are two concepts that you need to be familiar with, both in your everyday use of indexes and maintenance, but also for the purposes of the exam. And this is basically saying, for fill factor, what I'm saying is I know that I'm going to need to insert my address book for all my Scottish friends. I know that I'm going to insert more M's at some point. So I'm deliberately not going to fill every page. I'm going to leave blank spaces within my page. So what we're effectively saying is, when I build this index, I'm going to fill the pages to 60% full, 70% full, because I want to be able to insert new rows in those pages to try and avoid page splits.
And this is with fill factor, this is specifically the leaf level pages. We talked about these multiple levels, and this is where the actual data, or in the case of a non-clustered index, the reference to the clustered index is stored. I want to leave space there.
Exactly. So it's the leaf level, and this is the most used area. I'll explain pad index in a second. But fill factor, people will often have a generic best practice. If we have an example here, a fill factor of 70, but we've got this trade-off of, yes, that would prevent page splits, but what you're telling SQL Server is not to optimize the storage space. So you've got this trade-off of optimal storage space and performance versus page split. So you really need to know that you're going to get page splits to try and avoid them by using fill factor.
Otherwise, you've got a larger database taking up more space on disk and all the things that go along with that, the maintenance overhead of that.
Yeah. So one of the things that we would do to fix index fragmentation is to fill the pages properly so we can read more from a single read. And what you're doing with fill factor is say, don't store it efficiently, leave gaps in order for me to insert later rows. So it's not sufficient to have a generic best practice generally to say every index should have a fill factor of 60, 70, 80.
Otherwise it just would. That's how the system would work.
Yeah, exactly. Yeah. So certainly on most of the environments that I work in, we would have a fill factor of 100. So if you set a fill factor of 100 or 0, it basically means the same thing, which means fill the pages completely. And then we'd have more regular index maintenance.
And pad index?
And pad index. So pad index is basically the same as fill factor, but it's for the non-leaf level pages. And it will use, so you need to use fill factor and pad index together. So if you're experiencing or you're expecting page splits at the non-leaf level, so on your index keys, that's where you would use pad index to create gaps to avoid page splits there.
Okay. So let's just assume that I've managed to specify whatever fill factor is appropriate for my database. I'm still at some point going to get some fragmentation. I mean, inevitably, databases are things you add data to and you update. So some fragmentation occurs. What do I do about it?
So the first thing that you can do is rebuild. That's the first one that I'm going to talk about, and this effectively rebuilds the whole index. And this is the equivalent of creating the index from scratch, really. Things to bear in mind for this is that it needs free space in the database, so it's going to use some disk space to do a rebuild. But the main point that you need to remember from this is that it performs as a single transaction. So if you've got a very large index and you do a rebuild, some of the environments that we support, it can take 8, 10, 12 hours to rebuild an index because it's so large. If that fails 10 hours in, it's then going to roll back everything that it did. So it runs as an atomic transaction, this single transaction.
Okay.
So we need to be aware of transaction log space requirements when doing rebuilds.
All right. And then the other option?
So the other option is what we call a reorganize. And you can think of this as a defragment. So in the old world, it would have been an index defrag in older versions of SQL Server. So it's what we call a reorganize now. So this will sort the pages, and it does a similar job to rebuild. But the key thing here is that it's always an online operation. So I didn't mention before that an index rebuild by default will take the index offline. So if that's the clustered index, then the table is
Takes
offline.
The table offline,
effectively. Whereas a reorganize is always an online operation. It uses less transaction log space because it's not run as this single atomic transaction. So if the reorganize fails or you stop it, you still get all the benefits of what you've reorganized up until that point.
Just a bit like running good old disk defrag. You could stop it at any point, and it defragmented part of your disk, but maybe not all of it.
Yeah. Okay. So we've had some scenarios in the past where we've had customers with that would have a 10 terabyte clustered index table. With 99% fragmentation. They don't have the disk space to do a rebuild, but what they can do is a reorganize for a couple of hours a night over a period of a few weeks to try and catch up enough to rebuild the index and then do regular maintenance.
Right. And that will give them the benefits of defragging it a piece at a time, if you like.
Yeah, exactly.
Okay.
Exactly. So the other part to mention, so I mentioned rebuilding an index is an offline operation. And then we had this online index operations, which is a feature that came out in SQL 2005, I believe it was, where in the enterprise edition of SQL Server, you can specify an index to be rebuilt as an online operation. Which means that it's an availability technology, so we can keep the underlying table running, so we can have multiple users still using the database, so the concurrent user access. It's slower than the equivalent offline operation, because effectively what happens is that SQL Server will create a new version of the index and will rebuild that in the background, and then when it's finished it will switch the pointers over to the new index.
Okay.
So we've got bigger space requirements. It's slower than the equivalent offline operation. But we need to bear in mind this space consideration because we're effectively duplicating the database.
Oh, okay.
It also it enables you to rebuild an index online by using row versioning. Row versioning is supported by TempDB, so it can also cause a knock-on effect of TempDB space as well.
Okay.
So it's a great feature that's enterprise only, but it has a lot of overheads associated to it.
All right, great. So you've mentioned statistics a couple of times. I guess this is the missing piece of the puzzle now.
Yes,
Let's put that in.
So statistics are, again, they're separate objects. They're used by the optimizer to guess or to get a very good estimate of how many rows are going to be returned by an operation. So if you did a select first name, last name from employees, the only way that the optimizer is going to know how many rows are going to be returned is to actually run it. And if you've run it, then you've got the data, so you don't need the most efficient way to do it. So to get around this problem, SQL Server maintains a set of statistics, and the statistics store distribution details of the data within the table. So this example here, I'm using DBCC show statistics to show me the statistics for a last name column. And you can see at the bottom here, I have this range high key, range rows, EQ rows. So this range high key is basically what the optimizer has determined are range high keys in this, this histogram of the distribution of data. So let me explain how it works. It will make it a bit easier. So if we take a value of Abbott there as a surname, so I can see from this there are 200 rows that equal Abbott. Okay. And then for the surname of Adkins, there are 1,029 rows. So this is equality.
Right.
And between the values of Abbott and Adkins, I have 404 rows. There are two distinct values. Therefore, I'll have an average of 201.
Abby or whatever.
Yeah, exactly. So if I had a value of Abby or Acorn, then the optimizer would estimate that it's either going to be none or it's going to be 200. So I'll assume it's 200 and I'll base all of my my estimations and my execution plan based on those results.
And this is going to do things like help the optimizer decide if there's a whole bunch of discrete values in there and I'm searching for an individual value, then I'm probably going to want to use an index. If there's only two discrete values in there, I might as well just scan all the pages in there. It's just going to be quicker than looking up the index. Yeah.
If I'm expecting 100,000 rows from a 110,000 row table, I'm just going to scan the table.
Yeah.
And that's what you're helping the optimizer to do.
Okay. So I guess keeping those up to date is important then, but otherwise the optimizer is going to start making their own decisions.
Exactly. So as the data changes, we need to keep these statistics updated. And they're updated automatically by default. There's a flag on the database for auto-update stats.
Okay.
We can also do that on demand. So we have this auto-update statistics on by default, which is a database property. We can also issue an update statistics manually. So quite often what you'll find is under a performance problem scenario, this query is not running very fast anymore. One of the things you might do is to go and update the statistics to say, let's take another cut of the distribution of the data to try and help the optimizer have better guesses about what's going on.
Okay.
We've also got SP update stats, so this will update all the statistics in a database, whereas update stats is for specific statistics. And then finally an index rebuild. So the thinking behind this is if I'm rebuilding an index, I'm going to be reading all of the data anyway, so I might as well update the statistics as I'm going along. Because for every index you create, there'll be a set of statistics associated with that index based on the distribution.
Okay. So let's take a look at that then.
Great. So let's have a look at this previous demo, if we've still got the table. So remember in the previous demo, we created this phone log table and we introduced a lot of fragmentation here, and these were the results.
Yep.
So we had this 90% fragmentation, and we've got a 65% average page space used.
Okay.
So now we'll go ahead and remove that fragmentation. So I'm just simply going to do a rebuild of all the indexes on the phone log table. And we'll recheck that. You see, because it's small, it was very quick to go. Average fragmentation is now 0. Average space used is 99. And the page count as well is much smaller. So this is now reduced the size because we're far more efficient with how we've stored the data. We're reducing the size of the index.
Less overall pages that are more full now.
Yeah, exactly.
All right, so we've maintained some indexes. We've created some, we've maintained them, we've looked at some of the DMVs that we can use to query them. I've just missed out there. We use the covering indexes and the include clause to try and reduce the additional lookup once I've looked through a non-clustered index. Talked about filtered indexes, where in a non-clustered index, I only index certain rows based on...
So I can add a where clause to my index create,
Exactly. And like I said, we've just looked at the statistics that the optimizer uses to try and figure out, should I use an index, should I scan, what should I do, and then maintaining the indexes. So a lot of information in there about indexes, which I guess reflects how important indexing and index management is when you're implementing a database. or indeed if you're sitting an exam on implementing a database. So a good subject to drill a bit deeper in. Again, we finished the module, go and take a little time, absorb that, have a look in SQL Server books online, particularly at the create index statement and the rebuild and reorganize activities or statements that you can use to update your indexes or to maintain them and remove fragmentation. A lot of that kind of information is critical for not just building a database in the first place, but also for maintaining it and ensuring that it continues to perform to the level that you need it to. So great, we're going to take a little break from there, and we'll come back shortly with the next module, which is
using store procedures and functions.
Thank goodness you're here to remind me. Using store procedures and functions. Join us after the break for that. Thanks. So welcome back. We've so far in this course looked at tables and all things kind of tabular shaped, and then we looked at indexes and how we can create and maintain our indexes. In this module, what we want to do is to focus on stored procedures and functions. So we're getting more into the idea of using the database as a place to implement programming logic and actually build applications. So to talk us through that, once again, we have Christian with us. So I'll hand over to Christian. What are we going to cover in this module?
Perfect, thanks Graeme. So first of all, we're going to start by looking at what exactly is a store procedure. So we'll define the store procedure. Then we'll look at a couple of examples of how we can implement store procedures and also parameterize store procedures. So what we mean and what that really looks like. Then we're going to introduce a term called parameter sniffing, which probably sounds a lot more exciting than it actually is, and how that can affect the performance of applications. And it's the cause of a significant number of problems based on the distribution of data. So that will be quite an interesting section to discuss. Then we'll define what a function is, and we'll have a look at scalar functions and table value functions, or TVFs.
Okay, sounds like we've got a lot to cover, so let's crack on. What's a store procedure, Christian?
So first of all, a store procedure, so there are a couple of ways that an application, or if you're interfacing with SQL Server, that you can execute T-SQL code. So the first of all, every statement could be issued by the application. So this is really everything that we've looked at so far. You're sending batches of requests to an application. And the other way is to store groups of these statements together as store procedures. And then we would give that store procedure a name. So these store procedures can have input parameters, which helps with reuse. It can have output parameters and can return sets of rows. And this is really what we're going to look at when we move on to and have a look at these demos.
Okay.
So some of the benefits of store procedures, first of all, it's a security boundary. So users can be given permission to execute a store procedure without having permissions to the underlying objects.
So if a store procedure queries a table, the person calling the store procedure doesn't need permission on the table?
Correct,
right.
Yeah.
Okay.
So as long as the person that owns the store procedure also owns the table.
Right, so that ownership chain has to be intact all the way down. Okay.
It's a way for us to enable modular programming, so it helps us to develop applications against SQL Server and keep them all stored within SQL Server, and they can also improve performance as well. So a single statement issued across the network, so you think an application talking to SQL Server would say execute this store procedure rather than execute this 1,000 lines of code.
So I don't have to hard code a lot of code in my middle tier or my data access tier.
Exactly.
And that has two benefits, I guess. One is it's less fragile because, of course, if the data structures were to change in the database, then the code might break.
Yeah.
And secondly, I'm not sending all of that across to be compiled and run again every time.
Exactly.
Okay.
And so if we just jump back the slide there.
Sure, yeah.
And we have a better opportunity for execution plan reuse. So we looked at a couple of execution plans in the last section, if you remember. And because the creation of an execution plan by the optimizer can be quite CPU intensive, so we try and reuse these execution plans as much as possible, and using store procedures and parameterized store procedures is a really nice way of reusing those execution plans.
So the optimizer will figure out the best way to execute the store procedure, compile that, and then that stays around in memory rather than having to be redone the next time.
Exactly.
Okay, great.
So here's an example of how we would create a store procedure. So it's just create procedure is the T-SQL that we would use. We're in the sales schema, and this is an example of get salesperson names. And then we have a bit of begin and select. So within here, we've got a select. We're joining two tables together. We're ordering it, and we've also got a predicate in there. So it's a very, very simple select statement that we've wrapped within inside a store procedure.
Okay.
So executing store procedures, we use the execute statement.
Okay.
And we can also use that to execute other objects such as dynamic SQL. And we would normally abbreviate that, as it says there, to exec when we're executing a store procedure. Yeah. So, and again, as we talked about referring to objects before, we would always use two-part naming conventions in terms of the schema and the store procedure as well.
So, exec sales dot get salesperson.
Exactly, exactly. Because as we discussed in the previous modules, the name resolution process would go through the default schema. If you had one, if you didn't have one, then it would go to DBO. So there's some extra work for the optimizer to do if you're not specific about the schema that your object is in.
Okay.
And again, exactly the same way of calling the store procedure. Within the store procedure, we need to qualify the object names as well for exactly the same reason as we discussed earlier.
Right, and I guess that the other added complexity here, I suppose, is that store procedure may not execute in the security context of the person who called it. It may have its own identity,
exactly,
with its own default schema or whatever. So.
Yeah, exactly. Yeah. So one of the things we do as a best practice then is to have a consistent naming convention and don't use the SP underscore prefix. So SP doesn't stand for store procedure. Think of it like a special procedure. So SP underscore is used for system store procedures. So don't use SP as a prefix when you're creating store procedures.
Yeah, I've seen quite often people use USP for user store procedure rather than a system store procedure.
Yeah, exactly.
Yeah.
And another best practice there about keeping to one procedure for each task. So if you create a single store procedure that has lots of logic and flow within it, it can make it very, very difficult to reuse execution plans. So a common example of that would be if you're on an application or you're on a website and there's lots of tick boxes, and depending on what you tick to what you search for, if that uses the same store procedure, that's going to generate a different execution plan every time it's executed, which makes it difficult to
because
reuse.
You've chosen different options. And,
because you're trying to do too much within a single construct.
Okay. Now, we've seen this before, actually.
We have indeed, yes. So as with when we were creating views, you can also use this with encryption option to protect any IP you may feel that you have around the definition of your store procedure. And again, this is most relevant, or you would most see this within third-party tools that publish part of their code within SQL Server, may choose to use with encryption because they feel like the design is their intellectual property.
But I mean, generally, I guess as it says there, if you're not producing a commercial product, if it's an internal business application you're using, you might be making a rod for your own back for troubleshooting.
It's really, really difficult to troubleshoot if you've got store procedures and even views that are encrypted, because you can't see the code within it, and if you've lost, the original code, then there isn't anything that you can do about it.
Okay, great. So, time for one of your world-famous demos, Christian.
You do flatter me, Graeme. Great. So I'm just going to use the AdventureWorks database. Right, let me get back. So use AdventureWorks. So I'm just going to create a store procedure here. So you notice that I'm using create proc just as a shortcut. I'm creating a store procedure called get blue products in the production schema, which is going to select some columns from the product table where the color is blue.
Okay, so a fairly simple, basic example.
So I could run that, but in this case, I'm going to wrap it up as a store procedure.
Okay.
And executing that store procedure is going to give me the same results as if I'd executed the query.
Okay.
Make sense? So there we've just created a very simple store procedure. I'm going to create another store procedure here called Get Blue Products and Models, just to show you here that we've actually got two select statements within this store procedure.
So we've got, I mean, if anybody's got experience with a different programming language, I hesitate to call it a function because that's something else, but if you were creating a method or a block of code that could be called, you can encapsulate a whole bunch of programmatic logic within the one store procedure.
Exactly,
right.
Exactly. So let's create that store procedure. We've got two select statements here. And the purpose of this is to show you that we can actually return multiple result sets with a single store procedure.
So there's two row sets being returned
Exactly.
from that one thing. Right.
Exactly. But there's actually a mistake in this, in the fact that the purpose of the store procedure is to get blue products and models, but we've actually missed off the where clause for the models.
So when you say a mistake, you mean a deliberate mistake, because we know you don't make mistakes.
Here's one I made earlier.
Right.
So what I'm going to do is, because I've already created the store procedure, I can't create it again. So I'm going to use the alter proc commands to alter an existing store procedure.
Right.
And you'll notice that I've added in my where clause in there to complete the query that I was looking for.
Now we've got the appropriate filter. And it's interesting, the alter proc statement there is, it's in effect the same syntax other than alter and create. It's identical to the create except for the bit that you fixed.
Exactly.
So really what you're doing is redefining the store procedure. You're not altering it, just changing a little bit of it, you're redefining what it is.
You're recreating it by using alter, yeah.
Yeah.
And then finally in there at the end it was just we can have a look at all the store procedures within this database by schema. So we can see the two that we created at the end there.
And again, the what you're getting out of there by default are the user store procedures. I'm not seeing any system store procedures.
Yes,
there.
that's correct, yeah.
All right, so that's how we implement a store procedure. The ones that you used there were fairly simple. I just wanted the blue product, so I encapsulated that in a store procedure. It's more likely I'd want to have a store procedure where I specify at the time I'm executing it what color I want, and I'm guessing that brings us on to parameters.
That's a really good idea, Graeme.
There you go.
So this next slide is about using input parameters. So as Graeme said, that we're wanting to get code reuse from using store procedures. And in this case, we're creating a store procedure called orders date status, which has two parameters of due date and status. So parameters have the at prefix. They can also have a default value, as we have here, so tinyint equals 5. And they can be passed, so when we're executing a store procedure, we can specify them in any order by name, or if we list out the values, then we can, as long as they're in the right order, then it will still execute correctly.
So when I execute it then, I could explicitly say at due date and then give that a value.
Yes.
Or I could just, as long as it knows the first parameter is the due date and the second one is the status. So
Yeah,
I could
correct.
do them by position, but I couldn't mix and match the two.
Exactly.
Okay.
And for output parameters, so you can see in this one we have an input parameter of date time and an order count of output. So we must specify output to create an output parameter when we declare it, and when executing the store procedure.
Right, so it's not just when I define the store procedure, I'm saying this is a parameter, but I'm not expecting it to be passed in.
Yeah.
It may be passed in, it may be input and output, but really what I'm going to do is take this value and pass it back to whoever called me.
Exactly.
And when I actually execute it, I specifically state this is an output parameter.
Yeah, and you can see in the diagram the example code there where we're executing get order count by due date, and we're specifying order count as the output there.
Right, and if I were, but just to extend this a little further, because I know some people will be coming from a developer background where perhaps they're used to using C# or whatever to call this kind of code, you would specify in your ADO.NET class that you're building to connect to the database, what's the direction of the parameter?
Yes,
is it input
exactly,
or output? Yeah. And back to, let's actually see an example of that.
Okay, let's just make sure that we are in the AdventureWorks database. So now we're going to create another store procedure. Notice that I've used create proc as a shorthand for create procedure. And we've now added this @color input parameter.
Okay.
And where we used to reference blue within the previous example, we've now referenced @color as well. So we're using this input parameter in place of this query.
And the syntax is like a variable, so
Exactly.
if I declare it as a variable. Yeah.
Exactly. So let's create that now. So we execute this store procedure now against red. So now we're able to reuse this store procedure for any color that we wanted.
Very nice.
So in the next example here, we've had a bug report come in saying that people are trying to use this store procedure. They want to use it for products that don't have any color at all. So they're trying to execute this, and we don't have any products. Now, we know that there are products that don't have a color, but we're not returning them at all. And that's because we need to deal with these null values that we talked about in the first session of dealing with nulls.
Because a null can't be compared to another null because they're both unknown.
Exactly. It's an absence of a value that can't be compared to anything else. So what we're going to do is alter the store procedure because it already exists, and we're going to add some code here to deal with null. So we're going to use isNull to be able to return values that have return rows that have an absence of color.
Okay.
And now we'll test that store procedure again. One for red.
So the red one works, and the null one works.
And the null one works. Let's just be sure about those result sets there.
No, of course, there's actually 4 because each one returns 2. Yeah.
There we go. So these are all our null values.
Right.
So that's an example, a very simple example of creating store procedures with input parameters.
Okay, fantastic. So parameter sniffing then.
Yes.
Hardly wait.
So parameter sniffing. So we talked about execution plans and the fact that execution plans can be expensive to create. So if you think you've got a really complicated piece of code that could literally be millions of ways that SQL Server could execute that code. So going through all of that work to find a really good way of executing that, wouldn't it be good if we could reuse that execution plan for subsequent executions?
With the same parameters, presumably.
Yeah, so exactly. So that's what SQL Server tries to do all the time. And then that example that we had about colors, and we added this parameter for red and blue, it's exactly the same execution plan because we've parameterized that code. Okay, which is great. But where we have examples of your data has an uneven distribution of what we call lumpy data. So you've got very few values, the technical term, yeah, lumpy data, where you have very few values of some data, but lots and lots of values of another within the same table. So the distribution is uneven. It can cause problems with what we call parameter sniffing. And parameter sniffing is actually this process of executing the store procedure, and we say that SQL Server would sniff the parameter, and then it bases the execution plan on that parameter, and every subsequent execution will be based on that plan.
So the problem we're trying to solve here would be if I had 200,000 products and 50,000 of them were blue, 49,000 of them were red, and one of them was white. The execution plan for the white one might be different from if it was blue or red.
Exactly, okay. And depending on who executed it first and which execution plan was cached would depend on whether you got the right execution plan or a very poorly performing execution plan.
Okay.
So options for resolving this. So we could recompile the store procedure every time. So this is a bit of a broad sweep idea for this. So rather than reusing the store procedure, we just recompile it every time. But as much as possible, we want to reuse these execution plans to save on CPU cycles. We could execute the store procedure with recompile. So whenever we call the store procedure, we can also do a with recompile there. So it's very similar to modifying the store procedure itself. And we could also change the store procedure itself within the code that we knew we had a problem with, to use this optimize for option hint to tell the optimizer which value to design this execution plan for.
So if I know that 90% of my queries are looking for a color that I've got a good quantity of, then we optimize for one of those, and it should most of the time work out best.
Exactly. Would you like to see a demo of that?
I would love to see a demo of that. Shall we have a look at a demo?
Look. Great. So in this demo, we're going to be using a database called PeoplePS, so parameter sniffing. And within here, I have a store procedure called USP country search. So basically, it's just searching for people within the people table. It's joining to a country table based on country as an input parameter.
Okay.
So it's very, very straightforward. So what I'm want to do is to return the number of people in a specific country. So I'm going to free the procedure cache because I don't want to use, I don't want this plan to be reused for this demo. So we're going to do, have a look at the actual execution plan for this. Let me rearrange my windows slightly here. So this is the execution plan when I'm searching for somebody from the UK. So it's running in parallel. We know this from these little orange discs. The contents of the plan isn't too important. We've got a couple of table scans and we've got a hash match. The way that SQL Server has determined the best way to join the tables together is via this hash join.
Okay.
Then I'm going to free the procedure cache and run the same thing for people from the US. So you notice I've returned a lot fewer results than I had before.
Okay.
So there's about 300,000 people from the UK.
So there's less US-based customers.
Yeah, exactly.
Okay.
And if we have a look at this execution plan, it looks a little bit different. What's important here actually is this nested loop at the end. So a nested loop, SQL Server, the optimizer will use a nested loop where it's got much smaller data sets. So we've got two different plans for two different executions of the same store procedure.
And the optimal one depends on if I'm looking for customers in the US, that's the optimal plan. But if the other one had been executed previously, I might then find myself using the wrong plan.
Yeah, exactly. So, so I'm not going to clear the plan cache now, and I'm going to do a search for people from the UK. So you'll notice that that's worked and it's returned 310,000 rows. If we have a look at the execution plan, we're using a nested loop. We've got big fat pipes traveling between operators here, which is an indication of lots of rows. Mm-hmm. But the interesting point here is to have a look at, we F4 this to look at properties. Mm-hmm. And we have a look at select. We can see this parameter list down here on the right. Mm-hmm. So the parameter is country, but we've actually got a compiled value of US and a runtime value of UK.
So it's optimized the query when it compiled it for US, and we've subsequently executed it with a different value.
Exactly.
Right.
Exactly. So what we're using here is a plan that is inefficient for this value because we've got this lumpy data.
Okay.
Where did we get to? So options to fix it, I mentioned with recompile. So every time we call this store procedure, I could do with recompile. That would get me that execution plan.
Okay.
And US would get me a completely different execution plan. So you notice when I did, I ran dbcc free proc cache, that was clearing everything out of the cache. Okay. Whereas with recompile, I'm effectively saying recompile this every time it executes.
Well, and this is when you call it, you're calling it and saying,
yes,
I want you to recompile this.
Yeah, exactly. So we're going to get the right execution plan every time.
Okay.
We could also use statement level recompile, which is quite good. So if you imagine that this store procedure has lots and lots of statements within it, it's hundreds of lines of code, If I'm using with recompile when I call the store procedure, I'm having to recompile the whole thing every time it executes. Whereas in actual fact, we can use a statement level recompile, which I've got here. So I'm going to change the store procedure to have option recompile. And what this will mean is that every time that batch, so that statement recompiles, every time that statement executes, it will be recompiled without having to recompile the whole store procedure.
So if the store procedure had multiple statements in there, but only one of them was subject to this issue,
yes, exactly,
then that individual part of the store procedure can be effectively recompiled. Right.
Yeah, so each statement within the store procedure will have its own execution plan, and we're just recompiling that subset. So now we have option recompile. If I run country search UK, I'm getting the right execution plan. So I'm getting the right execution plan for that. And then if I run country search US, I'm getting the right execution plan. So the nested loop is what we're looking for here.
Okay.
And another alternative is to use the optimize for hint. So what I may say is, rather than recompiling that statement every time, I know that while, back to it, here we are, while the consequences for somebody searching for the US and using the plan for the UK plan is minimal, but somebody searching for UK and using the US plan is quite significant.
Okay.
Does that make sense? So what I might say is, regardless of what you search for, I want you to optimize it for a value of UK.
And we'll take a small hit on people searching for the
Exactly,
US.
because people searching for US, there's only 5 rows anyway, so getting a bad plan is an immeasurable execution time difference.
Right.
Whereas the other way around, it would have been quite significant.
Okay.
So if we do free proc cache here and search for US, have a look at the execution plan.
And it's the original one with the...
Yeah, so we can see, even though we've just freed the entire procedure cache, we've compiled it with a value of UK and executed it with a value of US.
Right. Yeah.
Make sense?
Fantastic. Yeah, great.
Good.
Thanks for that. So we've sniffed our parameters. Let's take a look at functions now. So something different from store procedures. We'll have a look at functions.
So let's just clarify, first of all, what is a function. So a function is a routine that's used to encapsulate frequently performed logic. So some of the rules around a function, so it must return a value. There's no execution plan reuse. And there are a couple of types of functions that we're going to be dealing with: scalar functions and table valued functions, which can either be inline or multi-statement.
So, I mean, I guess the big difference in my stored procedure here is that rather than encapsulating a reusable chunk of logic that I want to use to perform a particular task, this is something that returns a value. It's really something where I can call it inline, I guess, in some cases, and get back a value. Okay.
Yeah. So implementing a scalar function, we have an example here. The thing about a scalar function is, or that defines a scalar function, it returns a single value and it will usually include parameters. So we're looking to call a function, we're giving it some data via a parameter, and we're expecting to get something back.
Oh, so in this case, we're passing it in a URL, like you might type in a browser, and it's returning based on the prefix of that URL, whether it's HTTP or HTTPS or whatever it might be.
Exactly, yeah.
Okay. All right, well, I guess you better show us one of those.
Yes. So let's just set up a new database in this situation. Now we're going to be creating a function called end of previous month that's going to return a date value. So it's going to be taking a date parameter in, and it's going to be returning a date value. Let's set that up and query the function.
I'm guessing just from the name of that, if I pass in the 5th of February, it will return the 31st of March, which would have been the 30th.
The 31st of January.
February, yes, you're right, previous month, yeah.
Yeah. So we have a look at a couple of examples there. So system date time. So here we have, we're in January now, so we've got 31st of December. And if we were looking at something in 2010, we've got 31st of December 2009.
Okay.
And this object property here, we can determine whether the function is deterministic or not. And it's not deterministic because we can't determine the value because we need a parameter coming in, and based on that parameter, it will produce a different result.
So just backing up for a second, because I think this is something that's important, and particularly in the exam, a deterministic function is something where you can predict ahead of time what value you're going to get back. If I have a function that adds two numbers together, if I know what the two numbers going in are, I know what the result's going to be coming back. But if I have a function that returns something like getDate as a system function, well, unless I already know what the date is, then I don't know what the result's going to be coming back.
Exactly.
I can't determine that without executing it.
Yeah,
right.
Exactly.
Okay.
Good. So that was just a very, very simple example of creating and using a scalar function.
Okay. So we talked about scalar functions. You're going to talk to us a little bit about table-valued functions.
Yes. So a table-valued function, or TVF for short, returns a table data type. So rather than returning a value, we're actually returning a table as a data type.
Okay.
So we have two types of table-valued functions. So we have inline TVFs. That has a single select statement, and then we have multi-statement table-valued functions that will allow you to construct, populate, and then return a table within the function itself. And we can use these to replace views when we need more complex logic to achieve those results.
Okay, so if it was dynamically generating something that was going to end up in a table rather than just querying existing tables, a function's a better way to go than a view.
Exactly, right. Yeah. So a bit more complex logic.
Okay, well, we're switching backward and forward at a rate of knots here, but let's have a quick look at those.
So we're going to use the AdventureWorks database for this one. We're going to create a table-valued function, so we can see it returns table.
So it's specifically in that returns clause that I'm specifying this returns a table rather than an integer or whatever.
Yeah, exactly. So we're returning the result of this select statement. And so we're going to run this table-valued function, and see we're selecting from the table-valued functions, and this is providing for us the last two orders for this specific customer.
Right, so we're passing in the parameter of the customer ID and the number of orders we want, and that's what's being returned.
Yeah, exactly. Okay. So, and then the second part of this I wanted to show you was how you can use this cross-apply to apply the results of this select statement. Right. So we're using cross-apply, so we're going to evaluate this function that we've just created for every row that's returned from the above select statement.
Oh, so I'm using the same function for every row that's returned by the initial select statement. So I should get the last orders for every customer from that select.
Exactly. So let's run that, and there we go. So cross-apply is something that's really useful to be able to evaluate the results where you're expecting multiple rows coming out. And we use it a lot for troubleshooting some of the internal system views as well, and evaluating some of those dynamic management functions that we were reviewing earlier on.
Okay, right, great.
Good.
So that pretty much takes us to the end of that module.
Yes.
And we've looked at two main kind of sections there, I guess. One was store procedures, which are units of reusable programmatic logic to perform a task, and I can pass in parameters and I can get output parameters to return me values. And then I guess if you haven't compared the two before, it can be slightly confusing sometimes. There are store procedures that are functions. Functions are generally things that are used either inline in a piece of code to return a specific value, or to encapsulate something like we saw, to return a table where I pass in parameters rather than query a view.
Yeah.
So a fair amount of stuff there to look at. If you're prepping for the exam, then there's a whole bunch of things there that you need to be looking at. Go through the examples that we saw. Again, we'll be including the code as a download from this course. So go through that, but definitely have a look at SQL Server books online and have a look at the data in there, the information there about implementing stored procedures and implementing functions. And in particular, take a look at the difference between the two types of table functions. It can be quite important to be able to distinguish between those.
And as with the other modules, use these topics as marker points in your learning. Everything that you need to learn about these, it wasn't contained in this module, but they're really important things that you definitely need to be aware of and familiar with for the exam.
Yeah, fantastic. Okay, so hope you've enjoyed that one. Go off and do a little bit more studying on stored procedures and functions, and then come back and make sure you join us for the next module, which is all about transactions.
That's all in this episode. I hope this tutorial was helpful. In the next episode, we will start new topic, which is managing transaction. Is your mind ringing with questions, queries or doubt? Do you wish to learn more? Then visit our website www.millionlights.org and post your questions on our forum. We will be really happy to clear all your doubts. If you missed anything and want to rewatch it, you can download it from our website or can watch online as well. You can also participate in our webinars, discussion with the subject experts, as well as get Microsoft certification on various courses through our website. You can also find us on Facebook by the name Millionlights and also on Twitter. For more such interesting tutorials on coding, app development, programming and building rich UIs, keep watching Microsoft Hour of Code brought to you by Millionlights. Thank you.